Admiral Zafira Talnith stared at the holographic display floating above her command table, her four arms crossed in what her species considered deep contemplation. The Galactic Council's emergency session had been called for a reason that seemed almost absurd. Yet the implications were terrifying enough to summon representatives from across 47 different star systems. "So let me understand this correctly," she said, her translator converting her native clicking sounds into standard galactic. "One of our daughters studied human engineering practices, and now she's requesting permission to implement what she learned on a planetary scale." The council chamber fell silent. 36 alien species, each representing different aspects of galactic civilization, turned their various sensory organs toward the central display. The image showed a young Velthari female, barely past her second molting, standing beside what appeared to be architectural blueprints that defied every known principle of safe construction. Council member Thrix, a blob-like creature from the gas giant Noxara, spoke first. His voice bubbled through the universal translator with obvious concern. "The issue isn't just what she wants to build, Admiral. It's that she's already started." The display shifted, showing aerial footage of Kepler 442b, a previously uninhabitable world that the Galactic Council had designated for terraforming in approximately 800 years. The timeline had seemed reasonable, slow, careful, methodical, the way civilized species approached such monumental tasks. What they saw now made several council members emit distress calls in their native languages. Where there should have been barren rock and toxic atmosphere, sprawling cities now stretched across 3 continents. Massive towers pierced the clouds, connected by bridges that seemed to ignore the basic laws of physics. Atmospheric processors, each the size of a small moon, hung in perfect orbital formation around the planet. Most disturbing of all, the atmospheric readings showed breathable air for 17 different species types. "How long has this been happening?" Admiral Talnith asked, though she suspected she already knew the answer. 6 months, Thrix replied. She started the project immediately after returning from her exchange program with the humans. The room erupted in a cacophony of alien voices. Some species clicked, others hummed, and a few made sounds that the translators couldn't even process. Admiral Talnith raised all 4 of her arms for silence. 6 months, she repeated slowly. What we planned to accomplish in 8 centuries, she's done in 6 months. That's not even the concerning part, interrupted Dr. Clemeth, the Xerian representative whose species was known throughout the galaxy for their logical approach to problem solving. The concerning part is that everything she's built actually works. Our engineering teams have run 17 different analysis protocols. The structures are not only stable, they're more efficient than anything in our databases. The Admiral's mandibles clicked involuntarily, a sign of extreme agitation among her people. She had heard rumors about human engineering practices during her own military campaigns. Stories of ships held together with something humans called duct tape and prayer. Tales of humans fixing critical life support systems with spare parts that weren't even designed for the same purpose. Most disturbing of all, reports that these improvised solutions often worked better than the original designs. "Show me the engineering reports," she demanded. The holographic display shifted again, this time showing detailed schematics of the structures Zara Veltok had built. The young Velthari had taken everything she learned during her exchange year at something called MIT and applied it with the kind of enthusiasm that only came from complete ignorance of why something shouldn't work. The atmospheric processors used a hybrid design that combined Xerion environmental technology with what the humans apparently called aggressive overclocking. Instead of the careful, measured approach that would take centuries to show results, Zara had simply built processors 3 times larger than recommended and ran them at 400% normal capacity. The engineering teams had calculated that this should have resulted in catastrophic failure within days. Instead, the processors had somehow stabilized at these extreme parameters and were now producing breathable atmosphere faster than any terraforming project in recorded galactic history. "Look at this," Dr. Clemeth highlighted a section of the blueprint. "She's used Thurian gravitational manipulators as structural support beams. The Thurians designed those devices for delicate scientific measurements. Using them to hold up a building should be impossible." "But it works," Admiral Talneth observed. "But it works," the doctor agreed reluctantly. "In fact, it works so well that the buildings can adjust their own structural integrity based on environmental conditions. They're essentially self-repairing." Council member Vash, representing the Hive Mind Collective of Andromeda 7, spoke for the first time during the session. When a hive mind chose to communicate individually rather than through their collective consciousness, it usually meant the situation was serious enough to warrant immediate attention. "We have analyzed the probability matrices for these construction methods," Vash stated in the emotionless tone that characterized their species. "The chance of success should have been approximately 0.001%. The fact that not only did she succeed but exceeded all projected parameters by several orders of magnitude suggests that human engineering principles operate outside our understanding of logical construction methodology." The Admiral felt a familiar chill run down her spine. During the Third Galactic War, she had witnessed human ships continue fighting even after sustaining damage that should have left them as floating debris. She had seen human engineers rebuild faster-than-light drives using components from food replicators and waste recycling units. At the time, she had attributed it to desperate improvisation in wartime conditions. Now she was beginning to suspect that this wasn't improvisation at all. It was simply how humans approached engineering problems. "What exactly did she learn during her exchange program?" she asked. Dr. Clemeth consulted his data pad, his 6 eyes scanning the information rapidly. According to her academic records, she attended classes in something called creative problem solving, rapid prototyping, and failure analysis. She also spent time in what humans call maker spaces and participated in events called hackathons. Hackathons? The Admiral's translator struggled with the human term. Competitive engineering events where teams attempt to solve complex problems in artificially shortened time frames, Dr. Clemeth explained, often involving sleep deprivation and excessive consumption of stimulants. The humans seem to believe that optimal engineering solutions emerge under conditions of extreme stress and time pressure. Admiral Talneth closed her eyes and tried to process this information. In Velthari culture, engineering was a meditative practice that involved centuries of careful planning and gradual implementation. The idea of solving complex problems while sleep-deprived and overstimulated was so foreign to her understanding that her brain refused to accept it as a viable methodology. Yet the evidence was floating right in front of her. A planet that should have taken 800 years to terraform was now ready for colonization, completed by a recent graduate who had learned human engineering techniques. "There's something else," Thrick said, his gelatinous form rippling with what his species displayed as nervousness. "She's not done. According to her communications with the Terraforming Guild, this planet is just the prototype." The holographic display changed once more, showing a star map of the local galactic region. 43 planets, all currently classified as uninhabitable, were highlighted in red. A new overlay showed proposed completion timelines. "She wants to terraform 43 worlds in the next 5 years, Admiral Talneth read aloud, her voice barely above a whisper. "Using the same methods," Dr. Clemeth added, "overclocked atmospheric processors, improvised gravitational infrastructure, and what she calls aggressive parallel processing of environmental systems." Council Member Vash spoke again, their collective consciousness apparently reaching a unanimous decision. We have consulted our databases regarding human engineering methodologies. The statistical analysis indicates a pattern that we find disturbing. Elaborate, the Admiral commanded. Human engineering appears to operate on what they call the if it's stupid, but it works, it's not stupid principle. This methodology consistently produces results that exceed theoretical maximums while utilizing resources more efficiently than any other known approach. However, the process involves accepting calculated risks that other species would consider suicidal. Admiral Tal Neth studied the terraforming projections again. If Zara's timelines were accurate, the galactic housing shortage that had plagued the outer rim for 3 centuries could be solved within a decade. Worlds that were currently uninhabitable death traps could become thriving colonies capable of supporting billions of beings. The economic implications alone were staggering. Terraforming was currently the most expensive undertaking any civilization could attempt, requiring resources from multiple star systems and centuries of careful investment. If human engineering methods could reduce both the timeline and resource requirements by several orders of magnitude, it would fundamentally reshape galactic civilization. But the risks were equally staggering. If Zara's methods failed catastrophically, the resulting disasters could render entire star systems uninhabitable for millennia. "Has anyone actually asked the humans about this?" she finally said. The council chamber fell silent again. It was such an obvious question that the fact nobody had thought to ask it revealed how deeply the crisis had rattled everyone involved. Dr. Clemeth consulted his datapad again. "We could contact the Human Engineering Exchange Program. They maintain a liaison office on Proxima Station." "Do it," Admiral Talneth ordered. "And get me a direct communication link with this Zara Veltok. If we're going to evaluate whether to shut down her projects or authorize expansion, I want to understand exactly what she learned from the humans." As the council members dispersed to their respective tasks, Admiral Talneth remained staring at the holographic display of Kepler 442b. The planet now looked like something out of a science fiction fantasy rather than a real terraforming project. Cities that seemed to grow organically from the landscape, transportation networks that flowed like rivers of light, and an atmosphere that somehow supported life forms that had never evolved to coexist. Her military experience told her that anything this good had to have a catch. Nothing in the universe came without a price, and the humans had a reputation for engineering solutions that worked brilliantly right up until they failed catastrophically. But her scientific curiosity was stronger than her caution. If human engineering methods could really accomplish in months what traditional approaches required centuries to achieve, then perhaps it was time for the galaxy to reconsider its careful, methodical approach to large-scale construction projects. The question was whether they could afford to learn human engineering techniques, and more importantly, whether they could afford not to. As she waited for the communication links to be established, Admir, the communication array crackled to life 3 hours later, and Admiral Talneth found herself face-to-face with 2 very different individuals. On one side of the split screen was Zara Veltok, her purple chitinous plates gleaming with the confidence that only came from spectacular success. On the other side was Professor Sarah Chen, the human director of the Engineering Exchange Program, who looked like she hadn't slept in several days. "Admiral Talneth," Zara began, her enthusiasm immediately evident. "I'm honored to speak with you. I assume this is about the Kepler 442b project?" "Among other things," the Admiral replied carefully. "Professor Chen, perhaps you could explain what exactly you taught our young engineer here?" Professor Chen rubbed her temples and sighed. "Admiral, I need to be completely honest with you. We didn't actually teach her to terraform planets. We taught her problem-solving methodologies and gave her access to our engineering workshops. What she's done with that knowledge is... She paused, searching for words. Well, it's exactly what we should have expected, but somehow didn't. Explain. Human engineering education focuses on adaptability and resourcefulness, Professor Chen continued. We teach our students that any engineering challenge can be solved if you're willing to think outside conventional parameters and aren't afraid of calculated risks. The philosophy is that it's better to build something that works imperfectly than to spend decades planning something perfect that never gets built. Zara's excitement was barely contained. It was amazing, Admiral. The humans showed me these things called proof of concepts, where you build a small version of something just to see if it works. Then if it does work, you scale it up and improve it as you go. They call it iterative design. Admiral Talneth felt her mandibles clicking again. And you applied this to terraforming an entire planet? Well, yes, Zara said, as if this was the most obvious thing in the galaxy. I started with a small atmospheric processor, just enough to create a breathable pocket around my landing site. Once I confirmed the design worked, I built bigger ones. When those worked, I built even bigger ones. Each time I learned something new and made the next version better. Professor Chen was nodding slowly. This is actually a textbook application of human engineering principles. Start small, test quickly, fail fast if you're going to fail, and scale up what works. The problem is that most species take centuries to move from one iteration to the next. Zara compressed that timeline to weeks. How? Admiral Talneth demanded. I stopped trying to make things perfect, Zara replied simply. The Velthari approach to engineering requires that every component be tested for a minimum of 50 years before implementation. The humans taught me that if something works for a few hours, you can probably make it work for a few days. If it works for a few days, you can probably make it work for a few weeks. And if it works for a few weeks, you can figure out how to make it work permanently while you're using it. Dr. Clemath, who had been listening to the conversation from his position in the council chamber, interjected. That approach seems incredibly dangerous. What happens when something fails catastrophically? Professor Chen smiled grimly. That's where human engineering gets interesting. We don't try to prevent all possible failures. Instead, we design systems that can fail safely and recover quickly. We call it graceful degradation and rapid recovery protocols. Show them the atmospheric processor design, Zara said eagerly. The holographic display shifted to show a detailed schematic of one of the massive devices orbiting Kepler 442b. Admiral Talneth studied it carefully, and what she saw made her appreciate the elegance of human engineering thinking. Instead of building one enormous, perfect atmospheric processor that would be catastrophic if it failed, Zara had built dozens of smaller processors that worked in coordination. If one failed, the others could compensate while automated repair systems fixed the problem. If several failed simultaneously, the remaining processors would adjust their output to maintain minimum atmospheric requirements while emergency protocols activated. It's modular, she realized. Exactly. Zara's enthusiasm was infectious. The humans call it redundancy with adaptability. Instead of trying to build something that never breaks, you build something that keeps working even when parts of it are broken. Dr. Clemath was studying the schematics with growing amazement. These repair systems, they're designed to use materials scavenged from failed components. That's why the processors keep getting more efficient over time. They're literally evolving. Professor Chen nodded. Human engineering philosophy recognizes that complex systems will always encounter problems you didn't anticipate during the design phase. Instead of trying to anticipate every possible problem, we build systems that can adapt to problems as they arise. Admiral Talneth was beginning to understand why human ships had seemed so impossible to disable during the war. They hadn't been built to avoid damage. They had been built to keep functioning despite damage. "What about the gravitational infrastructure?" she asked. "Our engineers tell us that using Thurian gravitational manipulators as structural supports should be impossible." Zara's plates shifted to a deeper purple shade, indicating embarrassment. "Well, that's where I made my first major mistake." "Mistake?" "I was trying to build a bridge between two cities, but I didn't have enough traditional structural materials. I had several Thurian gravitational manipulators from a scientific survey that had been canceled, and I thought maybe I could use them to reduce the structural load on the bridge supports." Professor Chen was grinning now. This is classic human engineering. When you don't have the right tool for the job, you figure out how to make the wrong tool work anyway. "The problem was that I miscalculated the gravitational field interactions," Zara continued. "Instead of reducing the structural load, the manipulators created a localized gravity well that actually increased the structural integrity of the entire bridge by a factor of 12. Admiral Tal Neth stared at the young engineer. "You accidentally discovered a new form of architecture." "And then I figured out how to do it on purpose," Zara said proudly. "Now all my buildings use gravitational field manipulation as part of their structural design. They're essentially earthquake-proof, tornado-proof, and can handle environmental stresses that would destroy conventional buildings." Dr. Clemath was frantically making calculations on his datapad. "The engineering applications of this discovery alone could revolutionize construction throughout the galaxy." "Which brings us to the real issue," Admiral Talneth said. "You want to apply these same methods to 43 more worlds." "I want to solve the galactic housing crisis," Zara replied. "There are billions of beings living in overcrowded conditions on worlds that can barely support their current populations, while dozens of perfectly good planets sit empty because terraforming is too expensive and takes too long." Professor Chen leaned forward. "Admiral, I need to point out that from a human perspective, what Zara is proposing isn't actually that ambitious. We've been doing rapid, large-scale environmental modification for centuries. The difference is that we do it to worlds we've already ruined, while she's doing it to worlds that were never habitable in the first place. That's actually more challenging," Zara added. "Humans have the advantage of working with atmospheres and ecosystems that already exist. I'm building everything from scratch." Admiral Talneth felt a headache developing between her secondary eyes. The scope of what they were discussing was beyond anything the Galactic Council had ever attempted. Traditional terraforming projects required the resources of multiple star systems and took centuries to complete. They were carefully planned, methodically executed, and designed with multiple redundancies to prevent catastrophic failure. What Zara was proposing was the complete opposite: rapid deployment, real-time problem-solving, and systems that improved themselves as they operated. It went against every principle of safe engineering that galactic civilization had developed over thousands of years. But it worked. Kepler 442b was proof that it worked. "Professor Chen," she said finally, "in your professional opinion, what are the risks of allowing Zara to proceed with this expanded terraforming program?" The human professor was quiet for a long moment. "Admiral, there are risks with any engineering project of this magnitude. Traditional terraforming methods minimize risk by taking centuries to implement each phase. Human methods minimize risk by building in adaptability and recovery systems." "That's not an answer." "The honest answer is that I don't know," Professor Chen admitted. "Human engineering philosophy works because we're willing to accept short-term failures in order to achieve long-term success. We build things that might break, but we also build them to be fixable. The question is whether galactic civilization is prepared to accept that trade-off." Zara had been listening to this exchange with growing excitement. "Admiral, could I suggest a compromise?" "Go ahead." "What if I demonstrate the scaled-up terraforming process on a single world first? Something small, maybe a moon or asteroid that could be converted into a habitat. If the process works and proves safe, then we could discuss expanding to larger projects. Admiral Taloneth considered this proposal. A single test world would allow the Galactic Council to evaluate human engineering methods without risking a catastrophic failure that could affect multiple star systems. If the test succeeded, it would provide valuable data about the safety and efficiency of rapid terraforming. If it failed, the damage would be contained to a single, relatively unimportant location. "What kind of timeline are we talking about?" she asked. "For a moon-sized habitat? Maybe 6 weeks for basic atmospheric establishment, another 6 weeks for surface infrastructure, and then ongoing optimization as we add population." Dr. Clemeth's datapad made a sound that his species used to indicate extreme surprise. "Admiral, traditional terraforming estimates for a moon-sized habitat would be approximately 80 years. 3 months versus 80 years, Admiral Taloneth mused. And if it fails? Then we'll have learned something valuable about the limitations of human engineering methods, Professor Chen replied. Failure is data, useful data, even if it's not the data we were hoping to collect. Admiral Taloneth found herself caught between her natural Velthari caution and her growing curiosity about human engineering capabilities. The logical decision was to authorize the test project and use the results to inform future policy decisions. The emotional decision was to find the nearest bunker and wait for the inevitable catastrophic failure that her instincts insisted was coming. "One test world," she said finally. "Full monitoring by Galactic Council engineering teams, complete data sharing throughout the process, and if anything starts going catastrophically wrong, you shut it down immediately." Zara's excitement was so intense that her translator had difficulty processing the rapid clicks and chirps she was making. When she finally calmed down enough for coherent speech, her first words were, "Can I pick which moon to use?" Admiral Taloneth realized she had just authorized what might be either the greatest engineering achievement in galactic history or the most spectacular failure anyone had ever attempted. Somehow, she suspected it might be both. 6 weeks and 3 days later, Admiral Taloneth stood on the observation deck of the Galactic Council's newest administrative station, staring out at something that shouldn't exist. The moon of Zerath 7 had been chosen for Zara's test project because it was completely lifeless, had no strategic value, and was far enough from inhabited systems that any catastrophic failure wouldn't affect populated worlds. It had been a chunk of barren rock with no atmosphere, no water, and no prospects for supporting life of any kind. Now it looked like a jewel hanging in space. The atmosphere was clearly visible as a soft blue haze around the moon's surface. City lights twinkled across 3 continents that hadn't existed 6 weeks ago. Orbital installations that resembled nothing in any galactic engineering database moved in perfect synchronization around the moon, maintaining atmospheric processors, transportation networks, and what appeared to be defensive systems. "Status report," Admiral Taloneth commanded, though she wasn't sure she wanted to hear the answer. Dr. Clemeth consulted his datapad, his 6 eyes blinking in rapid sequence, a sign of extreme confusion among his species. "Admiral, I've checked our readings 17 times. According to our instruments, not only has the terraforming succeeded, but the moon is now producing more resources than it consumes." Explain. "The atmospheric processors aren't just creating breathable air. They're also extracting useful materials from the moon's core and processing them into construction materials. The industrial systems Zara built are apparently manufacturing everything they need for expansion while simultaneously building the infrastructure to support a population of approximately 50 million beings." Council member Vash spoke from their position near the sensor arrays. "Our collective consciousness has analyzed the engineering principles demonstrated on Zerath 7. The efficiency calculations exceed our mathematical models for possible resource utilization." Admiral Taloneth turned to Professor Chen, who had remained on the station to monitor the project. Is this normal for human engineering? The professor was studying her own set of readings, and her expression was a mixture of pride and concern. Admiral, what Zara has accomplished goes beyond normal human engineering. She's taken our principles and applied them at a scale we've never attempted. It's like watching someone take the concept of a bicycle and use it to build a faster-than-light spacecraft. Through the communications system, Zara's voice crackled with exhaustion and triumph. Admiral, the test phase is complete. Zerath 7 is ready for colonization. We're currently running at 127% efficiency, and all systems are stable. 127% efficiency? Admiral Talneth repeated. How is that possible? Well, that's where things got interesting, Zara replied. And Admiral Talneth could hear the grin in her voice despite the translation system. Remember how Professor Chen taught me about iterative improvement? The systems I built don't just maintain themselves, they actively optimize their own performance. Dr. Clemath was frantically calculating on his datapad. She's created self-improving infrastructure. The moon is literally becoming more efficient at supporting life the longer the systems operate. But that's not the best part, Zara continued. The manufacturing systems I built to create the terraforming equipment? They kept running after the terraforming was complete. So now Zerath 7 is producing surplus atmospheric processors, gravitational manipulators, and habitat modules. Admiral Talneth felt that familiar chill running down her spine again. Surplus? Enough to terraform approximately 6 more worlds of similar size, Zara said matter-of-factly. The manufacturing systems are designed to scale up based on available resources, and Zerath 7 has a lot more usable materials than I initially calculated. Professor Chen was shaking her head in amazement. She's accidentally created a terraforming factory, a moon that produces the equipment needed to terraform other worlds. Council member Thrix's gelatinous form was rippling with what his species displayed as extreme agitation. If Zerath 7 can produce equipment to terraform 6 more worlds, and each of those worlds could potentially be configured for similar manufacturing capabilities. Exponential expansion, Dr. Clemath finished. She hasn't just solved the terraforming timeline problem. She's created a self-replicating solution to the galactic housing crisis. Admiral Talneth closed her secondary eyes and tried to process the implications. Traditional terraforming was limited by the enormous resource investment required for each project. The Galactic Council could afford to terraform perhaps 1 world per century, and even that required careful financial planning across multiple star systems. But if terraformed worlds could produce the equipment needed to terraform additional worlds, the entire economic model of galactic expansion would change overnight. Instead of terraforming being a massive expense that drained galactic resources, it could become a self-sustaining process that generated its own resources. Zara, she said carefully, what would you need to begin terraforming those 6 additional worlds? Just transportation for the equipment and a few engineering teams to help with setup, came the immediate reply. Zerath 7's manufacturing systems can produce everything else we need. Oh, and I'd like to implement some improvements I've been working on. Improvements? The atmospheric processors on Zerath 7 are first-generation designs. I've been analyzing their performance data, and I think I can increase efficiency by another 200% while reducing manufacturing requirements by half. Professor Chen looked like she was trying very hard not to laugh. Admiral, this is what happens when you give a human-trained engineer unlimited resources and no oversight. They don't just solve the problem you gave them. They solve problems you didn't know you had. Dr. Clemath was studying the manufacturing data from Zerath 7. According to these readings, the improved atmospheric processors would be capable of terraforming gas giants. Gas giants? Admiral Talneth's mandibles clicked involuntarily. Not the whole planet, Zara clarified quickly. Just the upper atmospheric layers. You could create floating cities in the cloud layers that would support billions of inhabitants, and gas giants have enormous amounts of atmospheric materials that could be processed into resources for further terraforming projects. Council member Vash spoke again, their collective consciousness apparently reaching another unanimous decision. We have calculated the resource implications of the proposed expansion. If Zara's efficiency improvements are accurate, the terraforming projects could become resource positive within 18 months. Resource positive? Admiral Talneth asked. The terraforming process would produce more useful materials than it consumes, Dr. Clemeth explained. Instead of terraforming being a drain on galactic resources, it would become a source of resources. Admiral Talneth stared out at Zarath 7 again. The moon that had been completely worthless 6 weeks ago was now more advanced than most of the inhabited worlds in the galactic core. Cities that seemed to grow organically from the landscape supported infrastructure that outperformed anything in the Galactic Council's databases. Most disturbing of all, it was still improving itself. Professor Chen, she said finally, in your expert opinion, what would happen if we authorized Zara to proceed with the expanded terraforming program? The human professor was quiet for a long moment, studying the data streaming in from Zarath 7. Admiral, I think we'd solve the galactic housing crisis within a decade. I also think we'd completely transform how galactic civilization approaches large-scale engineering projects. And the risks? The biggest risk is that we'd become dependent on a technology we don't fully understand, Professor Chen admitted. Zara has created something that exceeds even human engineering experience. We're in uncharted territory. But, she continued, the alternative is to continue with terraforming methods that take centuries to complete while billions of beings live in overcrowded conditions. From a utilitarian perspective, the choice seems obvious. Admiral Talneth found herself thinking about the reports she received every month about overcrowded worlds, resource shortages, and the growing unrest among populations that had been waiting generations for new homes. The Galactic Council had been promising solutions for decades, but their careful, methodical approach to terraforming had barely kept pace with population growth. Now they had a solution that could not only keep pace with population growth, but could actually get ahead of it. The cost was accepting human engineering methods that violated everything galactic civilization had learned about safe construction practices. Zara, she said into the communication system, if I authorize the expanded terraforming program, how quickly could you have 6 new worlds ready for colonization? With the improved systems? 4 months per world, but I could start all 6 simultaneously if I had enough engineering teams. 4 months, Admiral Talneth repeated, per world. Actually, that's probably conservative, Zara replied. Once the manufacturing systems on each world come online, the timeline should accelerate. The 6th world would probably be completed in 6 weeks. Dr. Clemeth made a sound that his species used to indicate mathematical impossibility. Admiral, she's describing a terraforming rate that exceeds our most optimistic projections by several orders of magnitude. Admiral Talneth closed her eyes and made a decision that she knew would either save galactic civilization or doom it to spectacular failure. Authorization granted, she said. Full expansion of the terraforming program. I want engineering teams from every council species assigned to learn these methods, and I want regular reports on every aspect of the project. The communication system erupted with Zara's excited chittering before she managed to compose herself enough for translated speech. Thank you, Admiral. You won't regret this decision. As the communication ended and the various council members began coordinating the logistics of the massive engineering project they had just authorized, Admiral Talneth remained at the observation window, staring out at Zarath 7. Professor Chen joined her at the window. Second thoughts, Admiral? Many second thoughts, Admiral Talneth admitted, but also hope. For the first time in decades, We have a solution that might actually work. Human engineering often has that effect, Professor Chen said with a smile. We tend to solve problems by ignoring the reasons why they're supposed to be unsolvable. As they watched, new lights began appearing on Zerath 7's surface, the first manufacturing facilities for the expanded terraforming program coming online. In a few months, 6 more worlds would begin the transformation from barren rock to thriving habitats. Admiral Talneth found herself wondering what other impossible things the galaxy's young engineers would accomplish once they learned that the word impossible was really just a suggestion. The thought was still both exciting and terrifying in equal measure, but for the first time, excitement was winning. Al Talneth found herself wondering what other surprises the humans might have taught to the galaxy's young engineers. If one Velthari student could terraform a planet in 6 months, what could a dozen human-trained engineers accomplish? The thought was both exciting and terrifying in equal measure.